Function symmetry. So again, this is a review of a topic that probably you covered in depth in pre-calculus. There are two basic ways that functions can be symmetrical. One way that a function can be symmetrical is if it has reflection symmetry over the y-axis. Reflection over the y-axis. And it turns out that functions that have this include y equals x squared, y equals x to the fourth, y equals x to the sixth. In other words, y to any even power of x. And this is why we call this kind of function, symmetry, even symmetry. And notice it has the quality that if you go to the left a certain amount or go to the right a certain amount, you'll get the same output. So in other words, f of negative x equals f of x. That's an enormously important algebraic formulation of the symmetry. Now, of course, we can't have reflection symmetry over the x-axis because if something were symmetrical over the x-axis, it wouldn't pass the vertical line test, it wouldn't be a function. The other kind of symmetry that we can have is a function like this. And so what this is 180-degree rotational symmetry around the origin. And functions that have this kind of symmetry include x cubed, x to the fifth, x to the seventh, in other words, x to all odd powers. And so this is why we call this odd symmetry. And it turns out that if we go to the left and go to the right, well, what happens is that we get opposite values, opposite outputs on the left and the right side. So in other words, f of negative x equals negative f of x. That is an enormously important algebraic formulation of odd symmetry. And so certainly we can talk about powers of x, polynomials, as being even and odd. And certainly if we add a bunch of odd powers, we get an odd function. If we add a bunch of even powers, we get an even function. Notice that if we just have y equals a constant, y equals 3, for example, that is an even function, symmetrical on both sides. The trig functions are also enormously symmetrical. So, for example, y equals sine x, y equals tangent x, sine, tangent, cosecant, and cotangent, all of those are odd functions, whereas y equals cosine x and y equals secant x, those are both even functions. So it's very important to remember even and odd. It's very important to recognize it when it shows up. It's very important to remember the algebraic statements of what it means to be even and odd. And it's very important to remember which trig functions have which kind of symmetry. Again, all of these are things that should be studied in pre-calculus and things that you will need to know going into calculus.